Now we're given the functions f of x and h of x, same functions we had here, and we're asked to solve the equation f of x equals 0. Well, if f of x equals 0, then since f of x is x over 4 minus 7, we have x over 4 minus 7 equals 0, an equation which we very easily solve. I recommend, as always, if you have denominators, you multiply through by a common denominator. The only denominator we have is 4, so we multiply everything by 4, and we get x minus 28 equals 0, so that x equals 28. Now this tells us something about the graph, but I'll get to that in a little while here. Okay, then we have our inequality h of x less than 0. Okay, h of x being negative 2x plus 3, we get negative 2x plus 3 less than 0. Negative 2x is less than negative 3, so x is greater than 3 halves. And that also has something to do with the graph of the function. Then f of x equals h of x. Well, then we put the expression for f of x, our x over 4 minus 7, equal to the expression for h of x, the negative 2x plus 3, and we solve this equation. Again, I multiply everything by 4, then I just bring everything over to one side or the other, and I get 9x equals 40, so that x is 40/9, or 4 and 4/9. Okay, again, that tells us something about these two graphs, and somebody in class chimed up and told me exactly what that was. That was good. Okay, and we'll talk about that in just a second. Let's solve the equations first. F of x less than h of x, well, it's just like the last equation, except we have a less than. And when we multiply through by 4, we get this equation. I'm not going to read to you. And that leads us to 9x less than 40, so that x is less than 40/9. So, what do these solutions tell us about the equations? Well, setting f of x equals 0, since y equals f of x, that means y is going to be 0. So that means that the y equals 0 point occurs when x is 28. And that point is therefore the point 28, 0. That's for the f of x function. Now, just by dumb luck, it looks like my graph intercepted just a little to the left of 30, and that's pretty close to 28. Now, 28 might have been just a little further over here, but we see that by using this point and drawing a reasonably straight line, I lucked out and got really close to the actual x-axis intercept of that graph. So now we have the y-intercept and the x-intercept. So we can say that this point is 28, 0. I don't know why I wrote a 2 there, but let me fix that. Okay, now it reads 28, 0, that point there. Then h of x less than 0. What does h of x less than 0 mean? That means that the graph is below the x-axis, because the y coordinates of the points on the graph are going to be less than 0 when h of x is less than 0. Y coordinates less than 0 means points below the x-axis. So let's see, now that occurs for x greater than 3 halves. So what do we have? Well, we have this point here, which is three halves, 0. And for x greater than 3 halves, the values of h of x will be less than 0. Now I've depicted that with an arrow here indicating x greater than 3 halves, and this is regarded as a ray that goes on to infinity. Couldn't draw the whole thing. Okay, and I've got an open circle here, not sure how visible that is, but that represents the point that at 3 halves, 0, and of course this ray is down below the axis. It's offset a bit from the axis so it doesn't obliterate what we have on the axis. But this ray starts at x equals 3/2. Okay, does not include x equals 3/2. So that represents x greater than 3/2, and for those values, h of x is less than 0. Now, the x greater than 3/2 starts right after this point, so all the points from here on the graph of h of x are have y coordinates less than 0. Okay, the next f of x equals h of x, which occurs at x equals 49ths. Let's see how we did with that. Now, if f of x equals h of x, that means for some value of x, that means that the two graphs meet. Okay? Now that should occur at x equals 4 4/9. If I project this point straight up, looks like it comes closer to 5, but it's very plausible that this occurs at x equals 4 4/9. And we could, or 49ths, we could plug that back into the equation and find the value of y. We could plug it into either equation. We would get, if we plug it into the f of x equation, 49ths divided by 4 would be 10/9. 10/9 minus 7 is 10 minus 70/9, or negative 60/9, which would be about negative 6 2/3. Okay. Again, because of the anomalies on the axis, it looks a little lower than that, and the anomalies in graphing the equation, but it's plausible that this point is (49ths) negative 60/9, and that would not be negative 6 2/3. It would be negative 6 4/9, which would occur like along here. So we kind of missed it, but because of this being a hand sketch graph and because of the scale kind of spreading out as we move down, didn't quite work out as close as we'd like, but we certainly get the idea. By setting these two equations equal, we find the x values at which the graphs will meet. Very important quality, very important property of a graph. And then the last inequality, f of x less than h of x, occurs when x is less than 49ths. I don't want to clutter up the picture anymore, but remember, this occurs when x equals 49ths. Okay, the two graphs meet, and everywhere to the left of that point, which graph is lower? Well, this graph is lower than this one. From this point onward, forever to the left, the purple graph will be lower than the yellow graph, which kind of became the yellow and orange graph here, but the h of x graph. So that f of x certainly is less than h of x. F of x, being the purple graph, is lower than the h of x graph, all the way from here back to forever.